Okay, we're talking about three different types of chemical formulas today. Okay, so chemical formula, in case you didn't know, is basically representing our chemicals. Okay, so to be exact, right, it's going to display the element present. So it's going to tell me the element, but then it's also going to tell me how many atoms or potentially ions there are in this formula. Okay, so if we look here at CCl4, okay, CCl4. So first thing, let's break this down, right? C, if you guys forgot or if you didn't know, is carbon, okay? And then Cl is chlorine. Okay, so we have two types of elements here. Now this chemical formula, right, breaks it down to where it's telling me not only the types of elements we have, but also how many. So Cl4 is telling me that I have one carbon and four chlorines, all right, or chlorides. We'll explain that in a bit with nomenclature. Okay, so this is one carbon, four chlorines. Okay, and this is what chemical formula is. It's telling me the element and how many atoms there are for this compound. Now, there's three different types of chemical formulas we're going to talk about today. Yes, today we're talking about empirical, molecular, and structure. Okay, so we're talking about empirical, molecular, and the structure. Okay, so empirical formula is basically it's going to give me the relative number of atoms of each element in a compound. So how we want to look at empirical formula, just think of this as being the most simple formula. Okay, is basically going to tell me like if we got a compound, it's going to tell me the elements in the compound. So think of it as the most simple. The molecular formula, okay, this is where, all right, it's giving me more information. So the molecular formula is basically telling me the actual number of atoms in each element in the compound. Okay, so it's telling me now, right, how many atoms I have in that compound. Now the structural formula, okay, is basically it's going to tell me how this compound is arranged. So we're able to use lines to represent our bonds. Okay, so this is going to be showing us, right, how many atoms are in our molecule together, as well as now, right, because we know the structure, it's telling me how those things are connected. Okay, and I'll give you guys some examples later on as we'll go throughout this semester. But for now, understand that these are the different things that we can see with those with this type of formula. Normal lines basically mean that it's going to be in plane with the page. Dash lines means that it's behind, right, behind the plane. And then wedge lines means that it's forward. We're going forward here. Okay. So right now I'm just going to show you guys on the side here as far as the different elements that you might see over in this side. We got hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, and chlorine. Okay. Now, the reason why they look like this is because basically, once you guys get to organic, or if you ever seen like trying to build compounds, these are usually the colors associated with those compounds. I can't give you the reason. Yeah. So these are the colors that are associated usually with the compounds. So let's just look at a couple examples here. So we have the name of the compound. In this case, the first example is benzene. Okay, so benzene is the name of the compound. And this is what I was mentioning before. Think of the empirical formula as it's simple formula. Okay, it's going to give me some basic info about our compound here. So the empirical formula for benzene is CH, right? It's relative. It's telling me that I got carbon and hydrogen in this compound. It's not giving me any information as far as how many carbons or how many hydrogens I have, right? But it's giving me enough. I just know I have carbon and hydrogen. We'll actually go over how to find the empirical formula and molecular formula later on. Molecular formula is basically is giving me more information, right? So in fact, benzene has 6 carbons and 6 hydrogens, right? And then the structure, right, is going to be given in this formula. So like how I mentioned with the normal lines, right? The normal lines is just telling me that it's all in plane with each other, right? So they're in plane with the carbons here and the hydrogens, right? Nothing's going backward or forward. It's all in plane with each other. Okay, so with this structure formula, not only is it telling me what elements are there, carbon and hydrogen, not only is it telling me, right, how many atoms I actually have of both my elements, right? I have 6 carbons and 6 hydrogens. But now, right, this formula is telling me how everything is connected together. So in this case, with benzene, with the compound of benzene, we think of benzenes as a benzene ring. Okay, so they're in this ring-like type of structure with a double bond, single bond, double bond, single bond, double bond. I'm not going to get more to that right now. We'll cover that later on, but you guys will especially see that in organic chemistry. Don't be scared of organic chemistry, all right? If you got to take it, just go ahead and take that, all right? And then we have 2 other types of, these are models. So like I mentioned before, if we look on this side, these are the colors that are usually associated with those elements. So the ball and stick model, right? This is when you go to build these compounds together. Basically, right, we can know that if you ever see like a black, we know that black is carbon, right? If you see this type of white, opaque color, we know that it's going to be hydrogen, right? So this is the ball and stick model. It's just telling me once again how it looks. It's telling me how everything's connected still. Very similar to this formula here, but it's just modeled out. Okay, so it's really helpful as far as when you get to like how things are going to be attached, certain things are being replaced. Okay, and then the last model is just a space filling model. So this is more of a 3D aspect, right? So basically, for our elements, they have them as spheres. And the reason why, right, we understand we have the whole electron cloud around the nucleus, right, which we learned earlier. So that's how those elements are being represented. Okay, so this is, space filling models are really useful depending on what you're trying to do. Specifically, like if you have some type of compound you're trying to attach or see how they're could potentially like attach to each other, right, or reattach to each other. You see this with ligands a lot. Okay, but these are the 2 types of models you're normally going to see. Once again, so the ball and stick model, the basic type of way to see something real fast. Space filling gets a little bit more intense, but you can get more information from a space filling model with different types of densities, etc., like that. Okay, and these are the different types of formulas and 2 types of models that you should know going forward. Okay, and we have several other examples as mentioned before with the different colors.